Hello everyone, my name is Yevny and you're back on the ZHENATAN channel. Today I want to tell you about this homemade rolling machine which I use to roll metal strips for making hoops for wooden barrels. There are quite a lot of different designs for such rolling machines. They can be manual, like mine, or powered by an electric motor. But considering the small number of barrels I make throughout the year, a manually operated machine like this is more than enough for me. I spent a long time thinking about what design to use for this machine, and to save space you can see that I have very little room in my garage, so all the machines need to be compact, since they are placed along the walls. This is also because I still need to park my car in the garage. Well, to be honest, not my car, but my wife's. That's why I decided to make the machine compact in size, using one short solid shaft, and instead of another solid shaft, I made this little stub here, also on two bearings, but in its own individual housing. And with the help of a special system, well, a special mechanism, I adjust the distance between the rollers, which is a bit different from the standard approach. Basically now I'll tell you and show you everything and you'll see it all for yourself. Friends, here is the rolling machine. The design essentially is very simple. What is it made of? The base of the machine is a channel bar number 12, meaning it is 120 millimeters wide and about 35 centimeters long. The machine itself is mounted on these kinds of angled brackets, which are bent at a 90-degree angle. One side of the brackets is welded to the stove, while on the other side, holes are drilled for dowels, rods are inserted, and the brackets are welded to the rods. In other words, the machine is very securely fixed, making it quite safe to work on. Two plates are welded to the channel, that is to the base. These plates are 14 millimeters thick, about 100 millimeters wide and about 200 millimeters high. On top, these plates are fastened with a much thinner metal plate, about 6 to 8 millimeters thick, which holds the side plates in place and prevents them from shifting during operation. Holes have been drilled through the plates. Here you can see one hole, and here accordingly is the second one. The bearing housings have been made, which are attached to these plates with these screws. And through these bearings, a shaft is inserted on which one roller is mounted, the so-called drive roller, that is the roller that we set in motion. With the help of this kind of handle, this roller is set in motion, and accordingly, when we insert a metal strip here, the upper roller is also set in motion. Due to the force of friction and the pressure applied, the upper roller is engaged and the metal hoop is rolled. As for the upper short shaft, it should have appropriate adjustment so that we can roll strips of any thickness. Well, to be honest, from 1 millimeter up to a maximum of probably 3 millimeters. Usually, the design of this device features two solid shafts. On this far side, the upper shaft has a floating bearing and the longitudinal slot is milled into the support plate, allowing the upper shaft to be adjusted like this. Thanks to this, the distance between the rolling shafts can be changed depending on the thickness of the metal strip. I deviated a bit from the conventional design and decided to make a shorter shaft, almost half as long, which is mounted in a solid bearing housing that contains one larger diameter bearing and one smaller diameter bearing. The solid housing is inserted into a support plate in which a longitudinal slot has been milled. A bearing housing. The housing is secured with 4 screws. Now I'll unscrew one of the screws so you can see better. And here you can see that under each screw there is a milled longitudinal slot so that the housing can move in the vertical direction. In other words, these slots allow us, with the help of an adjustment screw, to easily change the distance between the rollers depending on the thickness of the strip we use to make the metal bands. In order to be able to adjust the distance between these rolling rollers, a plate like this is welded to the body, in which the adjustment screw is fixed. On top of the machine, another plate like this is bolted on and a nut is welded to it. And the adjustment screw rotates inside this nut. That is, we can decrease the distance or increase it. You can see that the bearing housing moves up or down depending on which way we turn the adjustment screw. Basically, for hoops you need to use a metal strip about 1.5 to 2 millimeters thick. For smaller barrels, the thickness is 1.5 millimeters for barrels of 50 liters or maybe even larger with greater volume. The thickness should be about 2 millimeters. I haven't run thicker strips through this machine, and in principle there's no need for it. As for the rolling rollers, there are two of them, the lower roller and the upper roller. Friends, on the lower roller there is a flange like this, about 5 millimeters wide if I'm not mistaken. Yes, 5 millimeters wide and 4 millimeters high. Accordingly, a groove is made on the upper roller so that when both rollers are brought together as much as possible, this flange does not press against the upper roller, but fits into this groove. What is this flange for? It is there so that when fitting the metal strip it does not slip off the rollers. In other words, this is a fixing flange. By the way, right next to the flange a knurling has been made so that the edge of the metal strip is better flared and the hoop takes on this kind of conical shape. We all know that barrels or tubs have a conical shape, and in order for the hoop to fit better against the wooden surface, we need to increase the contact area between the metal hoop and the wooden barrel. That's why we roll the metal strip so that the hoop takes on a conical shape. If we take a metal hoop, we can see that the diameter of the hoop at the top is smaller and at the bottom the diameter is larger. This depends on the size of the stave and the size of the barrel. The generally accepted difference in the width of the stave at the edge and in the middle is 8 to 12%. That is, for a tub, this is the difference between the width on one side and the other. And for a barrel, it's the difference between the width in the middle of the barrel, in the middle of the stave and at the edges. If the width of the stave is 100 millimeters in the middle, then at the edges the width of the stave will be 92 millimeters. That is 100 minus 8%, taking the minimum, so it comes out to 92 millimeters. The same applies to the tub. If on one side the width is 100 millimeters, then on the other, if we subtract 8%, it will be 92 millimeters. That's why we need to roll the metal strip to achieve the taper of the hoop for making a wooden barrel. Friends, the machine is essentially easy to remove. In other words, you just unscrew one bolt here and another one at the back, and you can easily take it off and move it anywhere you like. I unscrewed one side of the machine for better demonstration and to measure the dimensions of the rolling rollers. I turn the machine a bit. Now, regarding the external dimensions of these rolling rollers, so the width of both rollers is 40 millimeters. As I mentioned before, the width of the flange is 5 millimeters. The width of the groove, that is the recess for this flange on the upper roller, is also about 5 millimeters diameter. The diameter of the lower roller is 88 millimeters. The upper roller, on the other hand, is made in the shape of a cone, meaning the diameters of the upper roller on the outer and inner sides are different. The difference is about 1 to 1.5 millimeters. If the diameter on the outer side is 86.5 millimeters, then on the inner side the diameter is 87 point, about 7 or 8 tenths. So the difference is about 1 to 1.5 millimeters. Thanks to this, in addition to the knurling made under the flange of the lower roller, the taper of this roller allows us to press out the edge of the metal strip, thus giving the ring a conical shape. How can this machine be replaced? When I didn't have this machine yet, in order to give the ring a conical shape, or as our grandfathers did in the old days, they would simply hammer out one side of the ring on an anvil. That is, we hammer out one edge of the ring, and the ring takes on a conical shape, the exact shape we need to properly fit it onto a wooden barrel. Friends, as a drive mechanism on this device, we use a handle like this one. What else is there to say? Despite its compact size, this machine has proven to be very simple, very reliable, and with its help, it is quite easy to make hoops for wooden barrels. You, on the other hand, can make a hoop rolling machine of any designate. Doesn't have to be exactly like this one. If you have enough space, you can make it with 2 rollers. Make the rollers wider, buy 4 bearing housings online, attach them to some kind of support plates, and thanks to the length of the rollers, you can simply adjust the entire roller and thus press down one edge of the hoop. So it's not even necessary to make a conical roller. Just make 2 straight rollers, and thanks to their length, you'll be able to adjust the process. The main thing is to understand the operating principle of this device and what it's needed for. And it's needed so you don't have to swing a hammer to flatten the edge of the hoop. Let me tell you, that's quite a tedious and hard job. That's why I recommend making either this or any other device for rolling out metal strips, that is, for making hoops for wooden barrels. Friends, if you enjoyed the video, give it a like, share it with your friends, and subscribe to the channel. See you next time.